2? Why can't it hold 8? Think about the attraction. Okay, it could get unbalanced, okay. So think about, well, just the opposite is actually true here. Think about a magnet moving closer to a piece of metal. Right? So the closer you get that magnet to the piece of metal, the stronger the attraction becomes. And the harder it is to keep them separated. Same thing happens with that first energy level. Because they're opposite charges, they're going to be attracted. They're going to be so close to that nucleus that it's actually going to be very little space involved in it. Okay, so our first energy level can hold 2. Angel, how many can our second and third and fourth and fifth and so on and so forth hold?
4.
Double that. 8. Okay, so a total of 8 electrons. Remember, that's called the octet. Okay. All right. Good. Okay. All right. And we're filling up our electrons, our outer shell, with 8 electrons. Good. Okay. And then we continue adding energy levels until all of our electrons are filled. Let me ask you this. The outermost electrons. Does anybody remember the specific name we give to describe the outermost electrons? These are the ones that are involved in reactions. This is what determines their reactivity. They're called valence electrons. Okay? Just a term that we need to kind of think about. Okay? You good?
Yeah.
Okay. All right. So, let's get through this a little bit here. I want to get down to this guy. All right. So, John Dalton kind of created up all of these points that we've been talking about up to this point in time. Now, we're not really going to worry about this, remembering his name or anything, but I want you to understand the atomic theory. We talked about all of this. We know that matter is made up of atoms, and atoms are indivisible. What does that mean? Indivisible. We say that every time when we stand up and say the Pledge of Allegiance. Indivisible. What does indivisible mean? Not really. Indivisible. 0 is indivisible. Can't be divided, right? Can't be broken apart into something smaller. So atoms are that way. We can't break those atoms apart. Atoms in the element are identical in mass and in properties. This is the issue. Okay? This particular one right now, John Dalton did not know about isotopes. And I'm going to talk to you guys about isotopes today, and that's our lab's going to be kind of consistent of that. Isotopes are, well, we'll pause there. Okay, so number 2 is the big thing. Properties and mass, he felt, remain identical in all of those, and they actually do change. Compounds. What's a compound? Angel?
So the second one can hold 4, right? Or
no. The first energy level can hold 2.
Yeah.
Third, fourth, fifth, and so on can hold 8.
Oh.
Yep. For our intents purposes. Hey, you.
Compounds are a mixture between 2 or more things.
Okay. Can a compound be broken apart?
No.
By chemical means, it can, right? So a mixture is something that we could break easily apart, right? We have a mixture of M&Ms and Skittles. We could separate those, right? Easily. Might be a little bit difficult, but we could separate those. But it would be a little bit more difficult separating salt and water, right? It could be done, but it would be a little bit more difficult to separate them. So, compounds are formed 2 together. So when we form salt, you guys told me that sodium and chlorine gas are combined together chemically to form salt. That is going to keep its own unique properties. So those properties are going to change and give us different properties from that. Okay? Yeah, exactly. Yep. So when concrete sets up, there's actually a chemical reaction. If anybody ever used concrete, like they poured like a sidewalk or like a stoop or something, and you can kind of feel heat being given off, heat is a good idea that a chemical reaction is actually taking place. All right.
Kind of like what happens, like whenever you get your hair down or something.
Yeah, you can feel the heat on there because there's a chemical reaction taking place. Absolutely. The chemicals that are on your hair and on your scalp are causing your hair to change color because it's chemically reacting with your hair. Absolutely. Perfect. That's a great explanation. Okay. So Dalton's second postulate is basically his second thought on the atomic theory, was absolutely wrong. So atoms of the same element, they can be different. And the way that they can be different is actually containing different number of neutrons. So if we change the number of neutrons, that ultimately has to change the what? Mass number, right? Because we're either adding more neutrons or we're taking neutrons away. Now, is that going to change the charge of the atom? Victoria. Changing the number of neutrons. Does that change the charge of the atom? What charge do neutrons have? There's no charge at all, right? So they're not going to change the overall charge. It just happens to change the mass of it. Okay? They're called isotopes. And because of that, they're going to basically have different types of reactions that take place. Normally, isotopes tend to be radioactive versions of them, where they're going to kind of go in and change a little bit from that. Okay? So isotopes, and then on the back of your periodic table, if you could please write this down. Isotopes are atoms of the same element having different masses due to the varying number of neutrons. And that's where we're going to pause today. Yeah? It could be. Typically, when we look at isotopes, usually the atomic mass that is part of that is usually given in the name. So a radioactive isotope called uranium-235. If we look on the periodic table, if you find uranium, you actually can find a mass number of 238. So uranium-235 means that it has 3 fewer neutrons, and it's a radioactive isotope. Okay, so it's just a different type of it. They can kind of convert that around. Carbon-14, which is a very important isotope to date fossils. Carbon-14 dating is a radioactive dating method that we can calculate how much carbon-14 is left because we know the half-life of it. But it's different because it's heavier than, what's the atomic number of carbon? Charlie, what's the atomic number of carbon? Okay, and the atomic mass of carbon is? Good. So carbon-14, would that be heavier or lighter than the atom that we have there? Heavier, right? So it basically is left behind. So that's what we're kind of talking about today is the isotopes that we're going to look at in the lab as far as we go. So in this lab, I want your 2 cents. So go ahead and close down the Chromebooks, and we're going to take the periodic tables with us. So we're going to utilize them. We're going to be down in the lab for the remainder of the period. So as soon as the bell rings here, we'll take a little bit of a break. We're going to explain this lab here in some details, and then we're going to head down.
Hey, where's Chromebook?
Was there 2 there? Yeah. Can you send one back to Victoria? Thanks. Oh yeah, I'll get that. Okay. Guys, the one other thing that I wanted to get handed in today, if you do have it, if not, I will accept it tomorrow with no late penalty, is that form number 2, which is a parent form that is in that packet of information from you. If you don't have it today, since I did not get to see you yesterday, or to remind you, go ahead and you can get that turned in tomorrow at no cost. Okay, you'll get full points for that. If it's not turned in tomorrow, it's going to get, yep, you just get that signed right out of your pocket, get it signed by your mom or dad, parent or guardian. Okay, guys, have a seat. As soon as you get the Chromebooks put away, have a seat. Thank you so much. All right, so we're going to use pennies to basically investigate isotopes. Did I miss you? Okay. All right, keep this out on your desk, guys. We're going to go over this package just so we kind of understand. The big part of this particular lab, and I'll wait until you guys are ready.